Okay, so what we are going to do today is continue solving exponential and logarithmic equations. So some of these are pretty simple. So for example, with number 1, we already have x by itself, right? It's over here, nothing else on that side of the equal sign. So we can go ahead and do alpha window 5 base 1/4 of 64. Verify. And really the only thing we can do for verifying is just for this one is make sure we typed everything in correctly, and we did. So -3 is our answer. For number 3, we need to know what 2 to the 5th is. If you don't know that, you can press 2, a little up arrow thing, and there we go. So 32 equals x minus 4. So that means that x is 36. Okay. 2 to the 5th is 32, as is 36 minus 4. So that's it. Okay. Another kind that we're going to have is converting, so that's what we did on day 2. This is for when the variable is in the exponent. That gets it back down on the main level. If it's a log, then the variable would be in here, and so we would convert to get it on the outside. So log base 9 of 27 is 1.5 plus 5 and divided by 2. All right, so when we plug that back in to verify, we get 27, which is what we should get. So this one's good to go. All right. So what we're going to do for the rest of these is use logarithmic and exponential properties in order to solve. There may be conversion, there may not. It just depends on the problem. For this first one, we have two logs that are being subtracted from one another, so that is the quotient property. Both of these logs are equal to each other. They have the same base. So by the equality property, that means that the arguments are equal as well. Subtract 8x from both sides. We end up with negative 7x equals negative 16. So when we divide by negative 7, we'll get positive 16 over 7. So we're going to check each side individually, make sure that we get the So log base 3 of log base 3 of 16 over 7 minus log base 3 of 8 is that thing. So it is a weird decimal, but that's okay. We just have to make sure that it's the same as whatever we get from the second part. And indeed it is. There it is. So there we go. Okay, number 4. We have two logs with the same base. Remember, if there's no base written, it's a 10. And there's addition in the middle, so that means that we are multiplying. And then by the equality property, we can set the arguments equal to each other. Move the 10x over, and now we can factor. When we're solving by factoring, we set the factors equal to 0 and solve for x. We're going to leave that 2 on the outside alone because 2 can't equal 0. There's nothing we can do to make it equal 0. They're different values. So now we have 2 different values that we're going to have to verify. That's 10 of 2x squared is 3 plus log. Yeah. Log of 2 equals log of 10 times 3/2. Okay. Okay. We're going to do this one side at a time. So because this log doesn't have a base written out, we can just use the button down there. We can absolutely do the alpha window thing, but because there's no base, we just don't have to. Got the same number, so 3/2 works. So we can box that one. Now we're going to do the same thing, but with 1. So both of these work. It's entirely possible that we will have 2 solutions. That's completely fine. For number 5, there's 2 ways we can go about solving it. Both ways are completely valid. So one way that we can do this is by multiplying both sides by 2 to the x. Then we can divide by 4, convert it to a log. And we'll get -2. The other way that we can do this is by using the negative exponent rule. So 1 over 2 to the x is the same thing as 2 to the negative x. So either way, we get the same value. It just depends on which way you want to do it. Two to the negative 2 is 1/4, so that fraction gets flipped. 1 divided by 1/4 is 4. So that answer does work. Answer is negative 2. Number 8, that's the quotient rule. So we subtract the exponents. 5 minus 2 is 3. Take the square root or cube root of both sides. And we get 9. And that works, so 9 is our answer. Okay. The other kind that we are going to see is one like number 6. So I'm going to do something else first, so this isn't one of the problems on here. Okay, so here our bases are not the same. If they were the same, then we could set our exponents equal to each other and solve for x. So what we're going to do on one like this, and like on number 6, is manipulate the base to make them equal. So we can do this with exponentials. 8 is the same thing as 2 to the 3rd, because 2 times 2 times 2 is 8. So now our bases are the same because we can use the power rule. When we have an exponent and it's being raised to another exponent, we multiply. So 3 times x is 3x. And then we set them equal. So x is negative 1/2. And when we verify that, it is going to work. So same thing over here. We need to figure out what to the power of something equals 8 that raised to a different power will equal 1/16. And again, that's going to be 2. Multiply the two exponents together. Okay, verify that. Okay, we got 64, so as long as we get 64 from doing the other side, we're good to go. And we did. So our answer is 5/2. All right, so that's all the different kinds that we're going to look at this unit for solving. So if you need extra practice with conversion or with the properties, there is extra practice in previous days, so you can use that.